So, we had finished in the previous class that sonic, not sonic velocity, we had done with the nozzle flow, right? Nozzle flow, right? And we also had seen that what is the velocity when your nozzle flow is in normal, and what is the maximum velocity and what is the discharge corresponding to the maximum discharge, or corresponding to the velocity maximum, the discharge maximum, that also we have seen, right. Now, that if you remember, we had given that V0 was equals to under root 2 gamma p divided by gamma minus 1 into rho into 1 minus p0 by p to the power gamma minus 1 by gamma, right. This was our normal velocity, and velocity under maximum, or which we call it to be critical velocity, and this was under 2 gamma p, right, by gamma minus 1 into rho into 1 minus p0 by p to the power gamma minus 1 by gamma under critical, right. So, if we remember that it was like this, critical was that, okay, p0 by p, yes, w was, this was 2 by gamma, no, this was not this, this was velocity, okay, and w was given like this. W discharge was given as CD A0 under root 2 gamma p by gamma minus 1, right, and this with a rho, and this was p0 by p to the power 2 by gamma, and this was p0 by p to the power gamma plus 1 by gamma. This was normal discharge, and discharge under critical condition was CD A0, right, 2 gamma p rho by gamma minus 1, and this was p0 by p to the power 2 by gamma under critical condition by p0 by p to the power gamma plus 1 by gamma, right. So, this was our critical velocity under nozzle flow and critical discharge under nozzle flow or flow through the nozzle, right. And we had done also, we have all solved a problem. So, now if we see another problem, let it be here. If we see another problem which tells that, perhaps this problem we had done. So, this is another problem that it says air flows through a nozzle of diameter 1.3 millimeter having a discharge coefficient of 0.95 from a pressure of 5 atmosphere to a pressure of 1 atmosphere at 25 degrees centigrade. What is the maximum velocity and mass flow rate? Right? I repeat, air flows through a nozzle of diameter 1.3 millimeter having a discharge coefficient of 0.95 from a pressure of 5 atmosphere to a pressure of 1 atmosphere at 25 degrees centigrade. What is the maximum velocity and maximum mass flow rate, right? So, if we go back to that previous, which we have already written here, that in the nozzle flow the velocity is like this, and velocity under critical condition is like this, discharge was like this, and discharge under critical condition was like this. Now, what was that critical condition? If we just remember a little, that we said if the ratio of P0 over P, if this is equal to 0.528, then we call that this is under critical pressure ratio, right? Or the converse is also true, that if the pressure ratio P by P0 is equals to 1.893, then also it is under critical pressure ratio, that is called P0 by P under critical. This is also P by P0 under critical, right? So, if we apply that, right, and here in this problem we have been given that the pressure P is equals to 5 atmosphere and pressure P0 is equals to 1 atmosphere. We are also given a diameter, of D is equals to 1.3 millimeter is equals to 1.3 10 to the minus 3 meter, right? And we are also given that the coefficient of discharge, that is CD, is equals to 0.95, and temperature T is 25 degrees centigrade is equals to 25 plus 273 is equals to 8, 9 and 298 Kelvin, right. So, these are all given. Obviously, from the relation which we had given, that velocity V0 is equals to under root 2 gamma p by gamma minus 1 rho into 1 minus P0 by P to the power gamma minus 1 by gamma under critical condition. This, to know that we know P, we know P0, we know gamma we can not given, so we can assume it to be say 1.4 like the previous one. So, gamma is equals to 1.4 if we assume, right, and rho we have it has not been given. So, rho we can write equals to Pm by RT is equals to P is 5 atmosphere, 5 into 101,325 into air. So, we can say the molecular weight of air is 29. So, into 29 divided by R 8314 into 298 T. So, this comes to equal to, let us look into that calculator. Let us look into that calculator. 5 into 101,325 into 29 is equal to this divided by 8314 divided by 298 is equal to 5.93 is equal to 5.93 kg per meter cube. right? So if it is 5.93 kg per meter cube, then V0 from this we can write to be equal to under root 2 into gamma 1.4 into P 5 into 101,325 divided by gamma 1.4 minus 1 rho into 5.93 into under root 1 minus P0 by P critical. So, we can write 0.528 to the power 1.4 minus 1 divided by 1.4, right. So, if we start from here, so we can calculate it like this. This is 1 minus 1 bracket 0.528 to the power xy to the power 1.4 minus 1, that is 0.4 divided by 1.4, 1.4, right. This is equals to that is equals to this is equal to 0.166, right. So, this into 101,325, 101,325 into 5 into 1.4 into 2, this is equal to that divided by 1.4 minus 1, that is 0.4 into 5.93, 5.93. So, this is that is equal to 99749, right. So, hope we have done somewhere something wrong. Hope we have done somewhere something wrong. So, let us redo, that is 0.528 0.528 to the power 1.4 minus 1, that is 0.4 divided by 1.4 is this to the power is that, right. So, this is plus minus this. So, plus 1 is equal to 0.166, fine, into 101,325, 101,325 into 5 into 1.4 into 2 is equal to this, right, divided by 0.4 into 5.93 is equal to, so is equal to this. Okay, this is under root. So, if we take square root, yes, it is 315.83. equal to 315.83 meter per second. This is the velocity under critical or maximum velocity. So, maximum velocity is 315.83 meter per second, that is the velocity under critical pressure ratio. Right. So, this we have done. Now, we would like to see what is the discharge, no? And for that discharge under critical pressure ratio, we have seen WCR is CD A0 under root 2 gamma P rho by gamma minus 1 into P0 by P to the power 2 by gamma under critical pressure ratio minus P0 by P to the power gamma plus 1 by gamma under critical pressure ratio, right. So, if we now see that what is the A0, right, what is the value of A0? A0, because CD is given, so what is the value of A0 if we look at, then we can see that A0 is pi by 4 into d square, that is pi by 4 into d was given, d was given 1.3 10 to the minus 3 meter, right. So, 1.3 10 to the minus 3 square. So, this becomes equals to cancel pi by 4 into 1.3 into 10 to the power minus 3, right. So, this becomes that this square of this, now square of this is this, right. So, this becomes equal to 1.327 into 10 to the power minus 6 meter square, right. So, if that is true, then CD is given WCR critical condition, CD is given, CD was given 0.95, right. So, CD was given 0.95, A 1.327 10 to the power minus 6, and this is under root 2, gamma is 1.4, P is 5 into 101325, rho we got previously, rho we got 5.93, right. So, we got 5.93 by 1 minus gamma or 1.4 minus 1 into this times P0 by P critical. So, 0.528 to the power 2 by gamma 1.4 minus 0.528 to the power gamma plus 1, 1.4 plus 1 divided by 1.4, right. So, this is that. So, if we look at what is the value, So then let us start from the other end, that is 0.528 x to the power 2 by gamma, that is 1.4, right. So this is equal to that, minus how much, 0.528, so 0.528 to the power 1.4 plus 1, that is 2.4 divided by 1.4 is this, so is this, so is equal to this, right. So this multiplied by 2 multiplied by 1.4 multiplied by 5 multiplied by 101325 multiplied by 5.93, right. So this is equal to that, divided by 1.4 minus 1, that is 0.4, right. So much. So the whole is under root, so this become 2905, right. This become 2905. So that means again we have done a mistake. So let us redo, and first we check whether we have written everything. Oh, we have not done a mistake, my goodness. So after square root we have to add this, so this we have not given unnecessarily, we are redoing. So 5.528 to the power 2 by gamma is this, equal to this, minus 0.528 to the power 2.4 divided by 1.4, right. So this becomes that, right. And then the second one then is equals to 0.06. Earlier also hopefully it was like that, into 2 into 1.4 into 5 into 101325 into 5.93 is equal to so much, divided by 1.4 minus 1, that is 0.4, is equal to so much, under root of this is this much, into, which we missed last time, 0.95 is equal to this, into 1.327 into 10 to the power minus 6, 10 to the power minus 6. So this is equals to 0.00149, right. So 0.00149 So, it is then 0.001496, that means 1, 2, 3. So, if 1, 2, 3, 4, 5, 6. So, it is 1, 2, 3, 1.4 is equals to 1.4 into 10 to the power minus 3 kg per second, right. So, this can be made into kg per hour by multiplying 3600 is equal to 5.38 6 okay kg per hour, right. Now, the difference is that hopefully here it is differing, but 0.528 to the power 2 by 1.4 we have taken, right. 0.528 to the power 1.4 plus 1 by 1.4 we have done, right. 5.93 is the density we have taken correctly. 101325 we have taken for that, but perhaps 5 is missing here, right. So, from this value whatever we have gotten there, that is 6.69 10 to the minus 4. So, we know our value, this is 5.386. So, if we do 6.69 into 10 to the power minus 4 is equal, right, into 5 under root is this. So, it comes like that. So, we missed 0.0149 0.01496. So, we missed here somehow this term P, that is 5 into 101325, that should be there, right. So, correct it and then it is okay, right. So, correct in the slide that 5, this figure was not there in the P. So, that should have been. So, we have made it to Pascal, that is true, but somehow missed there. So, correct one is this 5.386 kg per hour or 0.001496 or 1.4 10 to the minus 3 kg per second, right. So, we have found out the critical velocity and critical mass flow rate, right. Thank you.